Hi, welcome to Graphing Systems of Equations. Graphing. Lots and lots of graphing, right? So, a system of equation looks like this one over here. Okay? It gives you two equations, and it's asking you to solve. And so, let's look at what a system of equation is. It's a set of two or more equations that use the same variables. So, in this equation, right, there's two equations, and they both use x and y. They both have x and y in them. And then we need to know that a linear system, in a specific system of equation as a linear system, is when each line has, or each equation of the system is a line. So we know these are linear because they are lines. When we graph them, they will be lines. So let's graph them. Okay? Solve the system by graphing. So we know we have to graph something. And the easiest way that I can graph this equation is by finding the slope-intercept form of the line. So I'm going to do it one at a time, and then we will graph the lines and see what happens. So to get slope-intercept form, we need y equals something, and that's normally y equals b, mx plus b, right? That's our slope-intercept form. So let's get y by itself. To do that, we need to subtract 2x from both sides. And those cancel, so we get 4y equals negative 2x plus 12. Then we divide by 4. And we can think of it as 2 over 4 is the same as negative 1/2 x. And 12 over 4 is just 3. So I just split those out. Now, when we're graphing, we already know that this is my y-intercept. So I'm going to go up to 3, and I'm going to draw a point because that's my y-intercept. Then I'm going to use my slope. So it's rise over run, 1 over 2. One of them has to be negative. So it's going to be up 1 over 2 to the left, or it's going to be down 1 over 2 to the right. And then I can take my line. I'm going to draw a line through all 3 points, and there we go. My next equation that I'm going to use is the one at the top, and it is x plus y equals 2. So x plus y equals 2. And again, I want to solve for y because I know how to graph that. I know how to graph that very, very easily. So I'm going to subtract x from both sides, and I get that y equals negative x, not negative 2, negative x plus 2. Okay, so then I know, again, my y-intercept is 2. I'm going to go up to 2 and I'm going to draw a dot. My slope is negative, right? Negative x, but that's the same as writing negative 1 over 1. So my rise is 1, and my run is negative 1, so I go up 1 over to the left 1, or it's down 1 over to the right 1. And then I draw my line again. So I'm trying to use different colors so you know very apparently which line is which. And then my solution, right? We want to know how to solve this. So my solution is going to be where they cross. And they cross right here. Okay? So the two lines cross in one spot, and that is your one solution. And that spot is negative 2, 4. So I'm going to say that that's negative 2, 4. And this is my answer. Okay? So you're always looking for where the two lines cross. Simple enough. Okay, these are those terms that we talked about. Alright, so they gave us a set of equations. What do we do if they don't give us a set of equations? What if we have to come up with them ourselves based off words in a problem, in a word problem, right? So we just have to look at what we have and take it step by step. 2 small pitchers and 1 large pitcher can hold 8 cups of water. 1 large pitcher minus 1 small pitcher constitutes 2 cups of water. How many cups of water can each pitcher hold? So we have 2 variables here. We have small pitchers. That happens in both. And we have large pitchers, which happens in both sentences. So I'm going to say, right, I'm going to label my own variables. I'm going to say that small is going to be represented by S. I'm going to say that large can be represented by an L. Because now I know exactly what I'm talking about when I'm talking about it, right? There's no guessing. We don't have to mark what X is and what Y is because it's very apparent that S represents small and L represents large. So that just helps me. So I have two small pictures. So 2S. And one large pitcher. So plus 1L. And that holds 8 cups of water. So equals 8. Then I have one large pitcher, 1L, minus one small pitcher, minus 1S, holds 2 cups of water. So equals 2. So that's all I had to do, right? I'm writing it down as I read it. And I'm going step by step by step, so I'm not overwhelmed by the amount of information that I'm given. If I go step by step by step and write down what I have, it's much easier. And it's much easier to think about. So, this is all I wanted. Because later on, we're going to learn how to solve other ways. And so, while the focus for this one is graphing, I also want you to focus on getting an equation based off of a problem, a word problem. So, solutions, right? There are multiple types of solutions. And the only one we can really find is when they intersect, like the picture on the far left. Okay, so we have one real solution. Because they only intersect in one spot, and that's at XY for this picture. Okay? For parallel lines, you have two lines and they never touch, right? So if they never touch, you can't have any solutions, so no solutions. So if you solve for y, and remember, if you solve for y and you get the same slope and different y-intercepts, then we have parallel lines, just by looking at the equations, or you can graph it yourself. If you see that they're never going to intersect, because they're parallel, then you have no solutions automatically. You also have the opportunity to have the same line. So if you go and you say y equals, and you get the same equation for your top line and your bottom line, then this has no unique solution. Because they're dependent on each other, so every point is a solution technically, right? So we don't want to mess with those because it has no unique solution. It only helps us if it has one solution so that we can have an answer. Okay? So those are your three types of answer possibilities. And these are your try these. So graph it. Graph the first one. It says graph, so graph it. And then find the equations that would be used to solve the problem, the second one. And that's it. Have a nice day.